In this tutorial, we will be talking about chain and position isomers. When we have more than 3 carbon atoms in a hydrocarbon chain, we need to specify where a side chain, a branch, or a functional group is located on the main chain. So we will need to specify the position at which the functional group or the branch is attached. And by the position, we mean at which carbon atom of the main chain. Let's take an example to make things clear. So we have two compounds over here. In these two compounds, the main chain contains 5 carbon atoms. So if we count as numbered over here, 1, 2, 3, 4, and 5, this will be the main chain and this is the branch. And if we counted also in this way, 1, 2, 3, 4, and 5, we will also obtain a 5 carbon main chain and a CH3 group or a methyl group will be the branch. If we examine this molecule, we will find also that the main chain contains 5 carbon atoms. And we have a branch or a side chain which is methyl. So in both molecules, the main chain has 5 carbon atoms and the side chain is a methyl group. Does this mean that these correspond to the same molecule? The answer is no. So these are two different molecules. So we need a way to differentiate between them. By using IUPAC names, we can differentiate in the structure between these two molecules. So we will be using a number which is sometimes called a locant to indicate the position of any branching or any functional group in a chain. So these are examples of structural isomers. In the next section, we will be talking more about the structural isomers. For now, you have to know that structural isomers have the same molecular formula, but they have different structural formulae. So structural isomers will have exactly the same numbers of atoms. However, these atoms will be bonded in a different way. Let's name these two molecules. So, as we said, the main chain has 5 carbon atoms and all the bonds are single bonds, so this is pentane. In the first case, we have a methyl group which is attached to the second carbon, so the carbon which holds the number 2. You may ask yourself, why didn't we count in the opposite direction? So we have 1, 2, 3, 4, and 5. And in this way, the methyl group will be attached to carbon number 4. Actually, when numbering the carbon atoms, you will number in a direction which gives the side chain, which means the branch or the functional group, the lowest number possible. So if we want to choose between 2 and 4, 2 is less than 4, and thus we will number in this direction. So we will write 2-methyl pentane. So pentane is the name of the main hydrocarbon chain, methyl is the name of the side chain or the branch, and 2 corresponds to the position of this side chain. On the other hand, if we take this molecule, so again we have a carbon chain of 5 carbon atoms where all the bonds are single as well, so this is pentane and the branch is methyl. Let's number the hydrocarbon chain to figure out the position of this side chain. So we have 1, 2, 3, 4, and 5. If we numbered from the opposite direction, this carbon will also have the number 3. So we have 1, 2, 3, 4, and 5. So this is 3-methyl pentane. So please keep in mind that when numbering the main carbon chain, you will number in the direction which gives the carbon atom holding the functional group or the branch the lowest number possible. And this is why we numbered in this direction and not in the opposite direction over here. Let's take another example. So we have these two sets of molecules. Let's examine the first set. Let's name the first one. So we have 3 carbon atoms in the main chain and all the bonds are single. So its name will be propane. However, we have one bromine atom attached to one of the carbon atoms. Let's check the position of this functional group, which is a halogen alkane. So if we count it 1, 2, 3, the number of this carbon is 1. So this is 1 bromopropane. On the other hand, if we examine this molecule and we use these numbers, then we will have 3 bromopropane. So again, we have 3 carbon atoms which are singly bonded. So we have propane and we have a bromine on the third carbon atom. However, if we count it in the opposite direction, so if we said 1, 2, 3, then the number of this carbon atom will be 1. So if we want to choose between 3 and 1, we will choose the lowest number, which is 1. So the name 3-bromopropane is wrong. According to the IUPAC rules, we have to choose the lowest number, which is 1. So these correspond to the same molecule because they have exactly the same name. So these are 1-bromopropane. If we examine this set now, so this bromine is located on the first carbon atom, so it is up here, whereas it is down in the second molecule. However, it is bonded to the same carbon atom holding number 1. And all these hydrogen atoms are equivalent, so we don't have any difference between these two bromine atoms. So these hydrogen on the first carbon are equivalent. And again, we have the same molecule whose name is 1-bromopropane. So you have to keep in mind two things, that when you have to choose between two positions, you will choose the one corresponding to the lowest number. And the second thing that you should keep in mind, these hydrogens are equivalent, which means that if you replace one and not the other one, you will have the same molecule at the end of the reaction.